Welcome to One Chemistry. Always try to do your best. Now, let us see about 100 concepts in organic chemistry. We are seeing it as episodes. This is the episode number 4. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The question contains 3 different compounds. One compound is a spiro kind of compound. Second compound is a twisted compound, which is B. And C is a kind of continuous phenandrine ring. It is attached with methyl. One is on above, another is on below. Here they ask you to find whether the chiralities exist among that or not. The chirality is the axis chirality, or the plane chirality, or the helical chirality. So from the answers you might guess the question is really about the origin of chirality. The answer is A. Let us see how. Let us see the first compound, which is contained chiral axis, meaning the compound is twisted one like twisted spirines. The methyl group and nitro groups are one is on above the plane, below the plane, other methyl and nitro is on the plane, or the compound naturally having the chiral axis there. Even though it doesn't have any chiral carbon, it contains the chiral axis, that's why it's chiral. Due to its chirality, the mirror image definitely don't overlap, so it is a chiral compound. Let us see the molecule B. The molecule B contains twisted architecture. It's a kind of twisted paper. If you twist the paper, it will be on different planes, right? One plane in another side, another plane in on different side. Same, this compound is twisted. The mirror image definitely won't match. Even though it doesn't have any chiral center, the chirality established by the plane. The same, the mirror image never overlap among this one. So it is a chiral molecule established by chiral plane. Then the molecule C. The molecule has 3 continuous rings and one methyl is above, one methyl is below. It's kind of started spiraling. Spiraling means it's like DNA. It's continuously rotating and spiking. So it's a spiral. If you create a mirror image of it, definitely it also won't match. So this is also chiral. Here chirality is established from helical form. So like DNA. So the answer is clearly A. A is chiral axis, B is chiral plane, C is helical chirality. So here you learn 3 concepts. Then the question number 2. Here you have 3 compounds. First compound contains 5 fluoromethyl group and it has diene. Next compound is cyclopropene and the compound C contains cyclopentane, which is in diene form, and it has 5 methyl attached to it. Here they are asking the acidity. How the acidity is here? Whether among the molecule A is better acidic, or B is acidic, or C is acidic. So the question is really about the stability versus acidity. Stability in terms of H plus donor. So which is a good H plus donor here? The answer is C. Let us see how. The concept of acidity coming from Bronsted. The Bronsted acid means it will donate H plus and anion. Here the anion is stabilized means you have best acid because the H plus donation will be easy. If anion is not stabilized, it is a poor acid. How the anion can be stabilized? By aromaticity as well as electron withdrawing group. So if you establish the aromaticity or the electron withdrawing group, it will be more acidic. Let us see the compound one by one. A compound. It should donate the electron, so H plus removal will be there, anion is formed. Here the compound is aromatic because it donates the H plus, it becomes 4n plus 2 electron, 6 by electron, so it is aromatic. As well as the negative charge stabilized among the resonance, as well as the CF3, the electron withdrawing group stabilized it. So many stability in the same system, so it's the most stable one, so best acid. B, if it donate the electron, it become anti-aromatic. Anti-aromatic means it's very much unstable. Then let us see the C. Once the electron is donated, it becomes anion, but it has electron donating methyl group. So it's partially destabilized by electron donating group, even though aromaticity is established. So if you look at the order, A is the best one, the next is C because it has aromatic stability, which is the dominant one, then next B. So the answer is C. The most acidic compound is A, then C, least B. Then the question number 3. The starting metal is linear compound which contains 3 alkyl group which having chiral center with S form, S configuration. Then you are reacting with pentanone, you are using the acid PTSA. They ask you to find the product. The product mostly ring closure, whether 5-member ring is formed or 6-member ring is formed, or the alcohol is above the plane, below the plane, or the inversion happened during the reaction. So from the question to product you might understand ring size is important and the stereochemistry fate is the real question here. The answer is C. Let us see how. The starting metal you have straight chain with many alcohol and you are reacting with ketone there. The diol groups normally protect the ketone, but which diol is formed, which alcohol is reacting is the question there. So here the two possibilities, whether ring closure is occurred with 1,2 alcohol and 5-member ring or 1,3 alcohol with 6-member ring. Here 1,2 diol is the major product, 1,3 is minor because the 5-member ring is more stable than 6-member ring if the ring contains heteroatom. So 1,2 diol is the major product, 1,3 is minor. Here you have to learn two important concepts. One is 1,2 diol protect the ketone, not 1,3 diol because of its ring size. So the chemoselectivity established here, only ketone is protected or carbonyl group is protected. Second thing is the stereochemistry. If you see the reactant stereochemistry don't change during the product formation. So the stereochemistry don't change during the production. Then the question number 4. The starting metal is conjugated ketone, it attached with methyl group. The product is epoxide. Here they given the 4 reagents. One is CPPA, perbenzoic acid. Another is H2O2ACOH, which is acetic acid and peroxide, and HCl and alcohol, and base and peroxide. From the reagents you might guess the question is about reagent versus selectivity, which one specifically form the epoxide there. The answer is D. Let us see how. The starting metal you are having conjugated ketone, which is double bond is there. If you react with peroxide, it always occur at the 1,4 addition. But the 4th position is not considered there, so charge travel back, it form epoxide. Here why this is possible, why not with other reagent? If you use CPPA, there are the many possibilities. Baeyer-Villiger oxidation and quenching possibility will disturb there. The other reagent definitely don't generate any anion and nucleophile. So the possible answer is D, which is hydrogen peroxide and base. Base abstract the proton from peroxide and it activates the nucleophile, which is HOO-. Here you learn the concept of soft and hard nucleophile. Soft nucleophile always attack 1,4 addition. The hard nucleophile always undergo 1,2 addition, which is normally methyl group, like not reagent. Then the question number 5. The starting metal is dibromobutane. They ask you to find the stable conformation. The conformation can be bromine nearby, bromine away, methylene nearby or methylene away. Here the question is really about bromine or methyl decide the structure and its stability of its form. The answer is B. Let us see how. Here the bulkiness of bromine very high when compared to methyl group. So bromine should be kept apart. The answer A contain bromine nearby, B contain which is anti, which is the furthest thing you can get, so it is a stable form. Other thing bromine is nearby, another thing bromine is adjacent. Here bromine achieved stabilized form by antiposition or 180 degree. So the answer is clearly B there. Here you have to learn two important concepts, which is bulkiness. Bulkiness is very important when you decide the structure. Here bromine is bulkier than methyl, so bromine decide the structure. To avoid the steric reason, the bulky group should be on antiposition, or you can say it kind of transposition. That's all from this episode. I hope it was useful. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.